Okay, welcome back to part 2 of quiz 1. And we left off at number 9. Number 9, it says Hooke's law states that, and A is the ratio of unit stress to unit strain is a measure of stiffness of the material, which doesn't sound too crazy. You figure if it's more stiff, then it doesn't stretch as much. But it's not perfect, so let's look at the next one. B is up to the elastic limit. Unit stress is in direct proportion to unit strain. And that sounds like it's right on the money, but let's look at the last two ones. The total elongation or shortening of a body is equal to PL over AE. And no, that's not what it says, but I can see how you get confused and say, oh, well, that's right. But that is not. It's actually B, but we'll go back and look at D. The strain or change in size of a body is caused by the external forces applied to that body. That is not Hooke's law either, so you just need to know what Hooke's law states, and it states kind of that elastic limit, or that elastic region right here, when it goes up before it hits the yield. And then it kind of goes up like that. But so this is typically your yield points are right about there. And it states that the unit stress is in direct proportion to the unit strain. The stress is in proportion to the unit strain in the elastic limit. So this is the elastic region here over. And that's when Hooke's law works. And it works pretty much perfectly for steel. Concrete, it's a little bit, you have to, it changes for the type of, or the strength of concrete, and then timber is not very well defined, so it's a little bit more difficult to figure out. But yes, it is B. Hooke's law states that there is pretty much an elastic limit, and it's a direct proportional ratio. Anyways, going on to number 10. The answer on number 9 was B. The moment of inertia of the section shown below about its centroidal axis is what? And it's 8 by 12. So 8 inch by 12 inch. The centroidal axis is right in the middle. We know this just because we know it. If you want to figure it out, everybody knows that it's a rectangle, so halfway, the centroid of rectangle is half. So you got what? 6 inches. And 6 inches. And you could do the Y if you wanted to do it from the bottom and find the centroidal axis, because if you don't believe me that it's halfway up, that should be pretty intuitive. You could do the sum of the your areas times distance over the area. So you would just do, but you'd have, it's at the middle. Actually, doing this, you would have to know that the centroid of the rectangle is halfway up anyways, so this really wouldn't work. You know where it is, so you don't do that. What you do is I equals B H cubed over 12. And this is for rectangular sections, plus AD squared. And AD squared is the distance, is the area times the distance away from the centroid, or the neutral axis as I call it. And since we're on the neutral axis, we're equidistant away from the neutral axis, the distance will go to 0. So we have the base, which is 8 inches, times the height, which is 12 inches, cubed over 12. We get that. The calculator says 8 times 12 cubed divided by 12 is 1,152 inches to the fourth. Let's see if that's correct, or if one of the answers. D, 1,152 inches to the fourth. And that is your answer. And thank you for going through quiz 1 with me. we'll go ahead and move on to section 2, or lesson 2, I guess it is, beams and columns.